Deep in the Cambodian jungle, there's an astonishing wonder of engineering, Angkor Wat. It was built way back in the 12th century by King Suryavarman II, and it is just enormous. We're talking about a literal stone mountain that just rises up out of the forest. And honestly, its very existence pretty much defies all logic.
Now, when I say enormous, I'm not kidding. The whole complex covers more than 400 acres. To put that in perspective, that's 4 times bigger than Vatican City. This makes Angkor Wat the single largest religious monument on the entire planet. But its size, that's only part of the story. The real mystery is how it's even still standing. You see, the Khmer Empire didn't build their masterpiece on solid ground. Nope. They built it on a swamp, a shifting waterlogged floodplain that gets absolutely battered by intense monsoon seasons year after year. So the question that has stumped engineers for centuries is this: how in the world did they build a colossal stone temple that didn't just sink straight into the mud?
To really wrap our heads around their genius, we first have to understand the sheer scale of the challenge they were up against. I mean, this wasn't just a difficult building project. By all accounts, it should have been completely impossible.
Okay, so the problems they faced were just immense. First off, they were building on this unstable, sandy soil that basically turns to liquid when it gets wet. Then, you've got the yearly monsoon rains which dump catastrophic amounts of water, threatening to just wash away any foundation. And they were trying to do all this while building a stone structure with a central tower as tall as the Sydney Opera House. The risk of sinking, cracking, and total collapse was just off the charts.
And yet, it's still standing today. The key, it turns out, wasn't just in what they built, but in how they controlled the very element that was threatening to destroy it, water. They didn't just build a temple, they literally engineered the entire landscape around it.
The Khmer were absolute masters of what we now call hydraulic engineering. They created one of the most sophisticated water management systems in the entire pre-industrial world. We're talking about a vast network of canals, moats, and these enormous man-made reservoirs called barrages. This whole system was centuries ahead of its time, and get this, it served 2 critical purposes at the exact same time. This system was just a brilliant stroke of genius. On a purely practical level, the moats and reservoirs kept the water table stable. This kept the sandy soil consistently moist, which prevented it from shifting around and collapsing. That was the secret to the temple's structural integrity. But, on a spiritual level, that very same water represented the cosmic ocean from Hindu mythology. You know, the sea surrounding Mount Meru, the home of the gods. The engineering solution was also a deeply profound religious statement.
Okay, so they solved the foundation problem. Incredible. But what about the millions of tons of stone they needed to actually build the thing? Well, that was a whole other kind of logistical nightmare.
Their main material was sandstone, and the closest quarry was at a place called Kulin Mountain, over 35 kilometers away. That's more than 20 miles. Every single one of the estimated 5 to 10 million blocks had to be cut and then transported that entire distance.
Just try to imagine the journey of a single stone. First, it was cut by hand from the mountain. Then, instead of being dragged over land, which would have been almost impossible, it was floated through that same incredible network of canals and rivers all the way to the construction site. And once it got there, the blocks were put together with such incredible precision that no mortar was even needed. They just fit together perfectly.
And all of this unbelievable effort wasn't just to build a big, impressive temple. The goal was to engineer a physical replica of the Hindu cosmos, an entire universe built out of stone.
You see, the temple's layout is literally a map of the heavens. The 5 central towers, they represent the 5 peaks of Mount Meru. The walls built in concentric circles are the surrounding mountain ranges. And that massive moat we talked about earlier? Yeah, it's not just there for stabilizing the ground.
It represents the legendary Sea of Milk from the Hindu creation myth. So as a visitor, you would physically cross this symbolic cosmic ocean to enter the realm of the gods. The engineering and the mythology are just completely intertwined.
And this fusion of ideas extends all the way to the sky. The entire temple is basically a massive astronomical device. It's aligned with such incredible precision that it marks at least 18 different astronomical events. The math needed to pull that off 900 years ago is just staggering. It was a way to honor the gods, for sure, but it was also a way to make sure every angle and every bit of weight distribution was perfect for keeping the structure stable.
So the water system was the secret to Angkor's success. It gave it stability, food, transportation, and spiritual power. But in a really tragic twist of irony, this great innovation would also become its greatest weakness.
For centuries, this hydraulic system was the engine that powered the Khmer Empire. But then, around the 14th and 15th centuries, severe environmental changes started to happen. We're talking prolonged droughts, followed by catastrophic floods. The whole network was put under immense strain. The canals filled up with sediment, the reservoirs failed, and the carefully balanced system just collapsed. And it took the civilization down with it.
The story of Angkor really leaves us with a timeless lesson. The very same technology that allows a society to flourish can also make it incredibly vulnerable. This relationship between our own ingenuity and the natural world is such a delicate balance. It's a source of both our greatest strength and our most profound fragility.
And that brings us to a final, pretty provocative thought. The Khmer Empire literally tied its fate to its mastery of water. Its greatest strength became its fatal flaw, which of course raises the question for us today. What is our greatest engineering feat, and could it also be our greatest vulnerability?